So we have f of z is equal to u plus iv. Okay, therefore what I will do is I'll just multiply this with I. This is a bit theoretical part. You have to practice this one, and in exam it is not necessary to write this one, but if you are writing, no issue, it will be well and good. So just we are multiplying this equation with I. So I into f of z is I into u, then plus I into I, here I square will come, I square b. What we did, we multiplied this with I. Okay, so I into f of z is iu plus I square b. So this I square is iu into I square is minus 1, so minus b. So I into f of z is equal to, we got iu minus b. Now say this is 1 and this is 2. Okay, so just add 1 and 2. So when we add 1 and 2, so 1 plus 2 is equal to f of z plus I into f of z is equal to 1 plus 2 we are doing, then right side is u plus iv, this is of 1, plus right side of 2 is iu minus b. Okay, so this is right side of RHS of 1, this is RHS of 2. Now this is equal to, now you can see here also you have real and imaginary part. So I will take this u minus b as one part without I, plus iv and iu. So I into will take that as b minus u, b plus u, or u plus v. Okay, this from here I is common, so it is u plus v, and from here you can see f of z is here, f of z is here. So that is f of z is common into 1 plus I is equal to, here u minus b plus I into u plus b. Okay, so this is what? This IV, this U and V. U and V we took together, and here IV and IU. Okay, so from here what we took, I is common. IU plus IV, it is IU plus IV. So I is common, and so it is U plus V is remaining. Okay, then we just took f of z common from here. Now what I am going to do here is, so now this is equal to this u minus b. U minus b I will give us p, some p or something like that, plus I into u plus v is q. Okay, so where this p is given as, where p is u minus b and q is u plus b, and left side is f of z is equal to 1 plus I z. Okay, 1 plus I into f of z. So this is p plus iq. Now since u and v are analytic, since f of z is analytic, u and v are also analytic, then we can apply Cauchy-Riemann equations here and all. So u minus v and u plus v we have here. So what we are going to do here, f of z is equal to 1 plus I into, so f of z is equal to 1 plus I is equal to, we got p plus iq, where p is u minus v and q is u plus v. Now I am just differentiating this one, differentiating this with respect to x. Okay, differentiating this with respect to x, this will become f dash z into 1 plus I, and here it is px plus iqx. Px means dou p by dou x, dou p by dou x, plus this is qx means dou q by dou x. Okay, so we took this one, f of z into 1 plus I equal to p plus iq. Now we are differentiating that with respect to x. So f dash z into 1 plus I is constant. Derivative of f of z is f dash z into this 1 plus I constant equal to right side dou p by dou x plus I into dou q by dou x. You can do even with y also. So be careful, but when you are doing with x, you are doing with x only, no y will come here, it will be x only. Okay, so this is dou p by dou x plus I into dou q by dou x. Now since this is this u and v, f of z is analytic, so u and v also will be analytic, and then you can say therefore p and q also will be analytic. Okay, so instead of this p,
partial differential
fine, this understood na, differentiate partially with respect to x. Okay, so this is now, so this is one formula. Now suppose now what is given here, look at the question, what is given here, you have been given u minus v is given. So in this one what is given, p is given. Okay, u minus v is given means p is given. So if p is given, you can find only px and py, right? So px and py means you don't have qx there. So what we do here is, since it is analytic, we have px equal to qy and py is equal to minus qy, like ux equal to vy, uy equal to minus vx, same way by CR equations. Why we can do like this? Because u and v are analytic, so, or f of z is analytic, so u and v are analytic, so p and q are also analytic. Since it is analytic, this by a CR equation. So px equal to qy and py equal to minus qs. So here what is given? We have been given u minus v is given. In question u minus v is given means p is given. So what we will do here, this is dou p by dou x plus, instead of this q, what we will write, instead of qx is equal to minus py. Okay, so this is minus I into dou p by dou y. This is the standard formula we can use in all the problems. So if p is given, therefore f dot z is into 1 plus I. If p is given, you will be using this. If q is given, what will we do? Px will be replaced by qy. Okay, px will be replaced by qy. So this is dou q by dou y will come. So you just remember this one only. In exam when it comes, what you have to do is, so first line we will write let f of z is equal to u minus v. Okay, then next line what you can write there is this one. This one you can write. So 1 plus I into f of z, not necessary to write all the middle steps. 1 plus I into f of z is equal to p plus iq, where this is important. That's why I wrote in red letters. So f of z into 1 plus I is p plus iq, where p is u minus v, q is u plus v. You need not show all these things. Okay, therefore this is f dot z into 1 plus I equal to dou p by dou x into I minus I into dou p by dou y when p is given. And if q is given, q is given means u plus v is given. If u plus v is given, then what you have to do, then f dot z into 1 plus I. 1 plus I is equal to px. This will be dou p by dou x will be changed by dou q by dou y. Dou q by dou y plus I into dou q by dou x. This you can use directly. Okay, when you use directly, there specify p is u minus v and q equal to u plus v. This should not be in the reverse order. Means if you are taking this is q and this is p, then there will be some changes. Okay, then corresponding changes will be everywhere. So do not do that mistake. Okay, so now here what is given in this question, so this is some part of that only, so you need not write it always. Into u dou q by dou x. Now here it is given, so given u minus v is equal to e raised to x into cos y minus sin y, this is given. Okay, that is what is given, that is u minus v is r, u minus v is p.
P.
So p is given, so that is p is equal to e raised to x into cos y minus sin y. So just you find dou p by dou x. So dou p by dou x means derivative of this with respect to x. So it is e raised to x into first into derivative of second. Derivative of this will become 0 minus plus second function cos y into cos y minus sin y second function into derivative of e raised to x is e raised to x only. So this term completely it is 0. Okay. So dou p by dou x is equal to e raised to x into cos y minus sin y. You can write directly this step, not necessary to write this step because it is understood. So dou p by dou x. Now dou p by dou y. Derivative of p with respect to y is first into e raised to x into, here both y terms are there. So derivative cos y derivative is minus sin y, minus sin y derivative is cos y. So one negative sign will come here. So minus e raised to x into sin y plus cos y. So this is px and py you got. So which formula you will use? Where we will have px and py. See this one. Okay. Therefore, f dash z is equal to f dash z into 1 plus I. Therefore, 1 plus I into f dash z from, say we will take this as 3 and this as say 4. So in exam when you write, what you have to write is, we will be writing this one. Okay, this one I will just highlight that with some other ink. So in exam when you have this question, write this, then you will be writing this step, this, and then obviously these two will be there. So depending on the question, if p is given, that you will write, and if q is given, that you will write. So this is not 3, this is 3 and this is 4. So if p is given, you will be writing this one, if q is given, you will be writing this one. So that is equal to, so here which one we will write? We will write third one. So dou p by dou x, this is equal to dou p by dou x minus I into dou p by dou y, this one, the third one. Okay, dou p by dou y. Dou p by dou y, and here again we are going to use Milne-Thomson method only. So this is equal to dou p by dou x means e raised to x into cos y minus sin y, dou p by dou x minus I into dou p by dou y is minus e raised to x. So this becomes plus e raised to x into sin y plus cos y. Therefore, by Milne-Thomson method, put x is equal to z and y is equal to 0 in, say, this one, in this, say this is 5. Now here 3, 4, 5 is because of all that equations, otherwise you can directly put. So this is 1 plus I into f dash of z is equal to, put here x equal to z, y equal to 0. So it is e raised to z into cos y means cos 0 minus sin 0 is 0 plus I into, here also again I into e raised to z into sin 0 0 plus cos y means cos 0. So we can write here 1. Okay, so this is e raised to z into cos 0 is 1, so 1 minus 0 is 1 plus I into e raised to z into, here 0 is 0 and cos 0 is 1, so 0 plus 1 is 1. So 1 into e raised to iz. So this is f dash 1 plus I into f dash z. Therefore, now here again you can see e raised to z is common. E raised to z into 1 plus I. See, e raised to z is common, so you will get this one. Therefore, what you will get here, f dash z is equal to e raised to z into 1 plus I divided by, bring this 1 plus means here it is 1 plus I into f dash of z. Okay, so now bring this 1 plus I to the denominator. So it is 1 plus I is here and you are getting this is equal to e raised to z. So f dash z is equal to e raised to z. Therefore, f of z means integral of f dash z, or integrating both sides. Integral of f dash z dz is equal to integral of e raised to z dz, which is e raised to z plus c. So the answer is f of z is equal to e raised to z.